Welcome everyone. This is the FX Masters program, lesson 4. All right, in this lesson we're going to talk about particle goals. We're going to continue talking a little bit more about particle fields. And we're going to use this lesson then to talk about stuff from the BBC Planet Earth, so meaning the FX prototyping portion. Remember my way of working where I cover some of the topics from the Maya FX Power User, some of the basic things, like the previous lesson. And then I try to apply them right away onto more complicated stuff from the FX prototyping. And then soon we can begin to tackle some of the avatar effects sections. Right, so as always, I want to remind you to refer to the FX Power User program for more detailed, attribute per attribute conversations. If you find yourself that I'm going a bit too quickly, or if I'm jumping ahead of something, you can always go back and use the FX Power User as a learning tool as well. So the topic then for the week, like I said, we're going to talk about goals. We're going to talk a little bit more about particle fields. This is the first episode of Planet Earth, like I mentioned before. And it does have some of the stuff that I want to talk about today. Here we go. So typical effect. Let me just go back a little bit. Probably because I don't have it on QuickTime. It's a shame. But this is a typical kind of effect that you will find not only on the nature shows. For example, recently I saw the new Star Trek film, which I can't remember its name. Well, I think it's Star Trek 3, let's say, of the new series. And the main thing about that film, the bad guys, they behave as a swarm. So they do have a swarm-like behavior and community and groups. So this is not only for nature. You can only it's being used quite a bit on films. So this kind of overall group, this is definitely a swarm. So let's talk a little bit about this. We're going to also cover the swarm when we get to the point we're doing the case studies. There is one for the Earth stood still, and that's pretty much what I did for months and months in that film, just working on swarms. All right, so I'm gonna go back a little just in case we need it for reference later on. We're gonna have it here. You've seen this reference before. I mean, many times. You may have seen it live if you're lucky enough. So let's see how we can get to something like this. Brand new scene. I'm not sure I can give you anything on the FTP for this lesson because we're going to do it from scratch. This is not something I've been planning. I don't have attributes and values set up in my mind. We're just going to go with the flow. Do a little bit of a tool as well. If probably something simple, as you know that I like to keep it simple always in my lessons. So let's see how we can come up. So to begin, you need to make a decision, as always, of remember the procedure. All right, if I'm going to be doing this for a shot on the show, what are the things that my boss or the director may change? And always remember, think, what is the worst thing that can happen? What are the worst case scenario for me? And try to anticipate and cover your back. So let's say, well, these kind of shots, usually, you don't see the particles being born. They're already kind of cut to the behavior, right? Already other particles are in place. Everything's starting to move, and so as far as the emitter type, you can be flexible with that. You can have multiple emitters, and that's probably what we can do. So I can show you a couple more things. So to begin with, I'm gonna continue working on the effects menu as always, and I'm going to create. There's no need to do end particles yet for any of these things. It's just a waste of resources. I'm going to create an emitter, just a simple emitter. Well, this is not a simple emitter. He created a volume emitter because it was the last one that I used. We can keep it. But what I meant by that is that you can create an emitter, go to the options, and then you can reset settings, and it will create an omni emitter as well. I think the idea of having the volume emitter is not bad. So let's keep it. Just, so they're born in a little bit of a bigger area, not just from a point. Let's give ourselves some more time. Hit play, and there we go. It's pretty much like how every effect begins, right? All right, cool. Get rid of the grid because we don't need that at the moment. And let's start basic. Particle goals, all right? So that's something that we haven't taught in this new course. It's covered in depth in the previous one. We're going to use particle goals for many things. We're going to use them for this effect, of course, that we're going to do right now. We're going to use them to detect collisions on objects in a cheap way. We're going to use it to fake footprints and impacts on geometry. Once we do like a big herd or a big pack of animals walking in the distance, generating dust impacts, we're going to use particle goals as well. Particles can be goal to surfaces, and we'll deal with that once we get to that point. But they can be goal as well to other particles. They can be goal to curves. They can be goal to a couple of things. And the idea of the goal is that the particle will have someone to follow. If it's a goal to geometry, then they will follow the topology of the surface. We're not going to talk about that today, like I said. But they can be goal, that's the most natural result you get. They can be goal to other particles. And that's what we're going to do right now. So at the moment, I'm going to continue like with what I have right now without doing any goals, so you can start seeing how things will evolve. We're going to give ourselves just a few particles to play with. I don't want to keep the emitter on continuously, right? So to recap, if you're going on a list, so what are the things that my director can change? Just like it happened with the flock of birds from the previous lesson, probably 2, I believe. The director can change the amount of birds on the swarm, or the density, let's call it in this case. And as you can remember, that is done with the count, the max count attribute right here. He can also, he might change how they will divide into subgroups, for example. So if they will follow multiple leaders. If you find video reference of the behavior of those birds, they tend to do that. And if you're thinking on a film where instead of being birds, for example, it's just a giant army of ships, just to say something, those ships may have different squadrons, for example, or leaders to follow. So the amount of leaders or how many subgroups you have, it might be something that he will want to change. Overall behavior, how close will they follow the leader, for example? That could be another attribute to tweak. Overall turbulence, overall direction, things of that nature. What if they, for example, release from a leader and then go into another? Or the whole, let's say that, for example, happens on a film where these ships are being controlled, as a swarm, and they have multiple leaders, right? And then the good guys, as always, they go in and then infiltrate themselves into the mothership, and they break the communications, and then all of a sudden the whole swarm behavior just breaks, and they don't know what to do, and they just kind of randomly move. Okay, so that the ability of doing that at a particular time, and then probably rejoining a leader later on. So the ability of going in and out of a swarm behavior, that could be something to add as well. So all those things are going to be covered, probably in my little system, and I need to make sure that I have enough flexibility to do it. So with that being said, let's see how many particles we have at the moment, just to get an idea. So there's about 15, almost 1,600 particles. So all right, let's say that we're going to have for now to play 1,500. So the emitter will put out 1,500 particles and stop. I think it's a little slow, the way they're coming into the scene. So I'm going to probably speed up the rate. All right, perfect. You've seen this before, nothing special. Okay, they come out in a spherical way because it's coming from a volume emitter where the away from center is activated. All right, cool. We know that because these guys, in this example, they're birds, and they're not going to die in midair. They're not going to disappear, right? So the lifespan of these particles, it's okay to stay as live forever. They conserve, Remember that we said that, unless it's for a very specific reason, it should never be 1. So the conserve of my particles, just I'm thinking, there you go. All right, so the conserve shouldn't be 1, so I'm going to put this to 0.98. This is the repetitive initial things that you can do, that you have to do. All right, so there we go. They obviously, because they have now conserved, they lose energy. There's nothing else to move them around. Let's change that. Let's do our double turbulence thing from yesterday. But I mean yesterday, I mean the previous lesson, I'm sorry. So I'm going to grab this, I'm going to go to fields, and I'm going to create a turbulence, which I can rename, remember, let's just do a shorter, turbulence high. This is my high frequency turbulence, no attenuation. Let's see if 25 as a magnitude is going to be fine. We'll select them, and let's see. All right, I'm going to move out so we can see them going crazy. All right, well, we have something. They're starting to look already like bees, maybe. But definitely have no purpose to, have no one to follow. They're just moving randomly around. But it works. If you saw the previous lesson, you know that having the phase attribute on this turbulence static is not really the best idea. So I'm going to put an expression on this. Create a new expression. You saw this on the previous lesson. If not, just go back one lesson and see how I did this. But basically, it's pretty much the same thing. I'm going to say time multiplied by 12. I'm going to put my finisher here, and then I'm going to use that twice more, just for the y and the z, and I'm going to offset this attribute just a little, so we don't have the same number on each channel. All right, perfect. Cool, you can see we have all 3. I'm going to copy this right away and have it in memory because I'm going to need it for my next one, my next turbulence field. So let's see what this does for us. There we go. Still feels like noise, and it's normal. That's that's basically what it is. The way it should work, the high frequency. Nothing special. But I'm going to grab them again, and I'm going to create another one. This guy, we're going to name it turbulence low. No attenuation. You see that I can work on the channel box and I can work on the attribute editor. It's the same. I'm going to grab my expressions in here. I'm going to paste them. But remember that you need to change the name of the field for turbulence low. You see, it's very, very quick. Once you start working along with these things, and another little cheat that I do is I just change, for example, set by switch it with X, or let's just put here Y, and then put here. Let me see. There you go. So that way it's faster. Instead of me changing these numbers, I just change the channel, and they're all different. Let me make sure that I did this correctly. Phase X, Y, yeah, that's fine. Okay, so the numbers are a little bit different on each one. Just to see the effect of one and the other, I'm going to switch the turbulence high off, and I'm going to stick to this one and see what it does for me. And the frequency, I'm going to lower it quite a bit. All right, perfect. This already shows you, right, what the big impact that the turbulence low is going to have on the overall behavior of this thing. If we go back to the video, you can kind of see these shapes described here, and then they're similar to what we see here. Right, it's obviously calmer in the particular stage. So let's wait for. We're going to do this as well. This is very simple. You can see this is a clear example, or the beginning of the swarm, or what I mean about when swarms don't have specific leaders to follow. They're not broken up into subgroups. They just move as a group all together at once. So we're going to have to build all that into a little system to be able to do this kind of stuff, as well as more intricate, probably more let's say acrobatic. Let's just wait for the next one. I think it's coming. Right, here's a bit more active. We're still moving as a group. But then they start to subdivide and separate. There you go. You can start seeing here. You see these curves, these shapes. Okay, so they're going to start coming through our turbulence load. That's why it's so important to have both. All right. Just continue to keep that around just in case. All right, perfect. So here's a turbulence low. Again, I'm pushing it a bit strong, just for the sake of this example. All right, cool. Now let's see them both working together. Let's put that to 25. You see how different it starts to look already. There's no goals, but they're already feeling similar to what we're going for. We have a couple things to tweak and solve, and we're going to give ourselves a lot of time, because this is something that is plays back so quickly, because only 1,500 particles that you need a lot of time to study what's happening. But it's looking nice. It's working. And like I said, there's no goals yet, but you can kind of see a little cluster here and a little group over there. Quite a few lost ones around. So this is definitely going in the right direction with just a couple of fields. Wonderful. You see how important the turbulence is. It's always needed. Very interesting shape, nice distribution. This is a nice 3D object. If this was meant to be for a stereoscopic production, then it's great because you have a lot of depth. You can see they're distributed very nicely. In a volume, let's say. All right, perfect. So we have that taken care of. So for now, I'm going to disable these two fields, just by putting the magnitude to 0. We get simple particle behavior here. And you see the difference? I want you to keep mental notes or actual notes of what's happening as we move around the lesson, because you can see that just by disabling the turbulence fields, then this thing looks more to me like a beehive or a bunch of mosquitoes or just insects in the air, right? Fruit flies or something. And I'm pretty sure that's something you're going to have to do at some point. For example, without going too far, an avatar. Avatar's jungle, which I don't know if I'm going to have one right on this video that I have here. Just trying to see if there's. But an avatar's jungle, there is one very important effects element, which is I'll look for it later, but which is the little bugs in the air. If you, I'm pretty sure that you have seen this film. If you haven't, just check it out because it's coming on the course. But if you see the jungles feel alive. They feel alive for many reasons. The plants move, and the lighting is interesting, and the shadows are active. But there's also a pass of little insects that just pollute the air. The air, let's say, that's just polluted. The same thing happens on a slower fashion, okay, on underwater scenes. Then you have little particles, and you have like Finding Nemo or any underwater show. You will see particles moving slowly on the surface. That makes it richer. That makes it more interesting, and it definitely makes it alive. And just by switching the two turbulence fields, and we start getting something that it can be used for another situation. And that's my whole point with this prototyping part, which is remember recycle your effects, and always find applications of one technique. I don't teach you how to do a specific effect. I'm teaching you a technique that you can mutate it and combine it with other into something else. Okay? Very, very important stuff. All right, I think we're going in the very, very right good direction very quickly. We're going to go ahead and save the scene. This is going to be the effects master lesson 4. And I'm going to specify on my file, just for myself, that this is the swarm part. All right, cool. Good. I want to double check something here very quickly. I want to see this. All right, so one of the fields didn't take the change, so I meant that I disabled both, and then we got the little fruit flies and all. It's just by disabling the low frequency, right? So the high frequency is giving me this little noisy behavior. So we keep that for later. So we know that once we I want to play, or the higher the value of the turbulence low, the more of a swarm of birds or a flock of birds is becoming. The less you have of the turbulence low, then it's more of a random, let's say, insect-like behavior. So we keep that in mind. I'm going to take that one and switch it off. And the reason why I didn't take it is because I should have done that, select both, and do it in the channel box. There, it will take the change for both. I did it in the attribute editor. That was my mistake. So right now you will see that without the turbulence field, it's just a simple particle emission, which is fine for what I want to talk about. Perfect. All right, now let's introduce goals. Let's see what we can do with that. A simple way of doing a goal, you can select the particles. Like I said, they can be goals to surfaces, locators, curves, other particles. I'm going to do with a locator just so you can see the effect very easily. I'm going to create a locator. I'm going to move this guy to the side. I'm going to probably, well, I could have duplicated it, but why not? Just create another one and put it to this side. I'm going to grab my particles and I'm going to select the locator, and you're going to go to end particles and you're going to gold them. The gold is under the create, the end particles menu. So we're going to go to the options, and there's nothing else other than the gold weight. I'll tell you what it is right now. Hit create. Nothing special will show up in your scene. It will just tell you a result in here, and on the particles, how do you know if it worked? If it doesn't give you an error, it means that it works. But if you select the particles as well, then you're going to have another attribute down here called gold weight and gold active 0. All right, I'll explain that in a second. Let me just see what happens if I hit play. And there they go. For the sake of the lesson, because these things move very quickly, this is 122 frames a second. That's just too much. It's 5 times faster than what it really is. I'm going to put my max playback speed instead of free or real time, just so you can see it a little better. So you see it at 24. That's what the particles are doing. So very quickly, what happens here is simple. The particles, I have told the particles to gold themselves to a point, pretty much, because the locator is just a little point. This is just the handle to be able to select it. But it's not that the locator is the entire thing, it's just the center. I have told all these points, 1,500 points, to gold themselves to that particular point in space. And I have told them to use a gold weight of 0.5. The gold weight is a number that goes from 0 to 1. And that's just, think of it as a percentage of attraction between the particles and the point in space. So 0.5 means there is a 50% attraction. So what happens? Well, the locator is calling the particles that are coming from the emitter. They're traveling towards it. But instead of stopping there, because there is only 50% attraction, they go past it. And then they return again and they go past it. And then slowly they will start to lose energy, and they will end up right at the center. So the gold weight is a very important number because it's going to dictate how these particles are, what's going to happen once they reach the destination. Are they going to stop there, or are they going to continue? You can see that if I put this, for example, 2.1, only 10% attraction, then there's a lot slower. Remember, there's no forces in here. They go past it. You can definitely see them turning. And they go again, and they start to circle this area until they lose energy and they stop. Or until I move this guy. He doesn't want to move. Let me just... Oh, because it's still playing back. 1 second. All right, perfect. If I move it, and I'm not going to rewind because now I have all my particles in here, you see? I'm not going to rewind because I want to show you what happens, right? So they go ahead and start following it. So that's what a goal will do. I'm going to hit rewind. I'm going to move this guy back. Now particles can be gold to multiple objects, not just one. I'm going to have them here. I'm going to select them. I'm going to shift select the other locator, and I'm going to gold them again. So right now, this particle system, it has a gold weight 0, gold weight 1, gold active 0, gold active 1. I don't want to say the word remember, but I'm expecting you to see some of the remembrance of the effects power user program lessons. And then if you saw that already, then you should remember that every list in Maya, a list is called an array. A list in Maya, the first item of the list, Maya will identify it with the number 0. So what this means is that this is the gold weight of the first locator that I selected, which is 0, and the second one is going to be 1. So that's how you will differentiate which one of the locators I'm talking about here as far as the gold weight goes. Same thing with the gold weight active. If you're going to disable one of them, you can just do it right here. So right now what's going to happen is that these particles have to divide themselves in a way where they have 50% attraction to the locator of the left, on the left side, and only 10% to the one on the right. And at this stage, when the points are static, you're just going to average a number in between. But if they were moving, then always the one on the left will have more impact on the particle motion of the whole group. So let's see. So you can see that this one is a lot higher, the influence, and then that guy is not doing too much. It's only 10%. I could move it, and you will see very, very subtle changes in there. Pretty much nothing, because this guy is so strong. So what you can do is just balance it. Let's say, for example, 10% in one and 50% on the other, then still be pulling to the left. But then any changes on the position of this one will influence the group a little bit more. You can see? So there we go. You can just move them. These particles will do whatever they can to comply with both. Let's say that I want to move that up and out. Then you can see that they get pulled 10%, but then the other one still wins because it's stronger. All right, cool. That's just particles goal to a locator. You can do that later. You can keyframe also the value of the attraction. Right now the goals have disappeared, and then what's happening? They have nothing to do. They just stay. They have no leader to follow, let's say. If I rewind and hit play, then I get my particle system again. Simple as that. So I don't want to gold them. I mean, you could gold them to a point and then do the swarm and then say that those are leaders and all, but that's not a very flexible approach. I want to be able to, for my client to tell me, Luis, I think this should subdivide into 3 groups. Then you run the simulation, and then, I don't know, I don't think it looks right. Give me 7 groups, and then give me 5, and then give me 1, and then give me 3. And if I have to start deleting locators and making new ones and animating them by hand, it's just going to be a nightmare for you. Excuse me. So what you want to do is just have another particle system that you can control separately with dynamics as well, and have the main group of birds follow them. That's the key for this kind of shot. So that's what I'm going to do. I'm going to grab, I'm going to create another emitter. And this one is just an omni emitter. I can place it here so you can see the difference. There are my particles, and here's my emitter. I made a mistake and I created an M particle system. And I don't really want to use that yet. I'll use it later in a different lesson. Let me just get rid of it. Let me get rid of the emitter and then make a new one. There. There are my particle. I mean, there's my emitter. And then my 2 particle systems. So these particles on the left side are going to be my swarm. And the emitter that will put them out, I'm going to call it swarm emitter. This guy's on the right side of the screen is going to be called my leader. And then we can call that leader emitter. So that way I can quickly find, what I'm doing here. So the leaders are going to be the subgroups, okay? So yeah, let's just say that the number of points are going to be breaking up the main group. So this is going to be a system with very, very few particles. So I'm going to use on my max count for now 3. Just 3 guys. And there they are. Perfect. And don't worry about this. Nothing to worry about. Okay. So I'm going to grab my swarm and I'm going to grab my particles. Remember that let's say that the slave is selected first and the master last. So if I do it like this, I'm going to grab my particles, I'm going to gold them. Okay, so you can almost, you can start to see roughly that the particle system divided itself. And some follow this guy, some this guy, and some that guy. It's very strong right now, the attraction, because my gold weight is set to 0.5. This list doesn't really update. I mean, doesn't delete the attributes of when I deleted the locators. So it kept gold weight 0 and 1 there. Let's just see if you can delete that. I don't remember. Let me see. Delete attribute. No. Let me see if I grab the shape node. No. It doesn't let me delete those, but don't worry about it. It's just for the sake of the example. Don't get confused. Remember, what I'm going to do is put this to 0 and that to 0 as well. And we're going to be working with gold weight 2, which is the new one. And I'm going to put that very, very low. I'm going to put it to 0.1 right now and see what happens. Let's see the difference. All right. It's getting better. Remember that there are no other forces on the scene. Let me just see where this error is coming from, because that doesn't make any sense. I mean, it's nothing that is breaking the scene, but I don't like to see that red thing down the bottom. Emitter type, emitter opacity, emitter emission. I find it stupid. I don't see what's a big deal there. Why is it erroring out? But there's nothing erroring out of my scene, though, as far as behavior goes. Everything is working. I get, and to be able to find the particles easier, the leaders, I'm going to, instead of making them points, I'm going to switch the particle render type to something called spheres. So that way you can quickly find them and see what's working and what's not working. So there they are. So it does work. And if I add more, then the Maya is going to divide the particles into all the subjects that you have, all the leaders that you have moving around. I think at this stage it's good to have to reconnect the turbulence and see what it does. So I'm going to grab them both. I'm going to put them at 25 and see what happens. It might be too much. So right now the particles have to find a way, okay, to satisfy everyone. They have to find a way to move around with the turbulence field and also respond to the gold weight that I have. And the force is quite strong. But there they are. They're aware of the leader. They just, they're being moved by the turbulence field as well. And on this kind of shot, you have to keep in mind that these guys, these little spheres, are not going to be visible. This thing is acting up. Okay. They're not going to be visible, so don't worry about it. All you need to focus is on these guys. I have them set to spheres just so you can see them right now, because obviously we're learning this. But when the time comes, these guys, these 3 spheres are not going to render. They're just going to sit there. That kind of effect. But I think right now it's kind of hard to see them move, to follow something. They just kind of look, all of them look a bit uniform still. Yes, there is noise and there's turbulence, but I don't see them getting too close. So I think it's time to add up the gold weight 2 a little bit. And just try 0.25. Just zoom in. All right, cool. Okay, perfect. So you can see it's definitely working. We might need some more. Obviously we're gonna make some changes. Right now, I hate that error, man. It's driving me crazy. There might be something. Form shape, letter shape. I think I know what it is. Let me just see something here. Let me just copy this. Okay, you can see that the error is gone. What I think it was happening is that when I renamed the field, I didn't rename it on the channel box. If I rename it here or the outliner, then both the shape node and the object, I'm sorry, the shape node and the emitter itself, they changed names. But I think I was trying to remember what I was doing. I think when I renamed one of them, I renamed just the shape node, or I didn't do it right. So that's what it was erroring. I was kind of not recognizing its own shape or something stupid like that. But I think it's fine now. So we can play, we can escape, and yeah, that's fine. Everything's working. Okay, so we're gonna keep tweaking this to make it look more realistic. What I don't like right now about this, well, a couple of things. One, the first thing I don't like is just the motion of the leader themselves. It's just kind of boring. So I'm going to connect the leaders to a turbulence field. I could do it to one of these guys, but I think I just want to keep it separate. So I'm going to call it turbulence leader. You could do a high and a low frequency. I'll leave that to you when you have more time at home. For now, I'm just going to put that to 0 on the attenuation. And the frequency, I'll put it to 0.5. And I'll put it to 10. And I'm also going to take the conserve of those particles, and I'm going to lower it to 0.98 as always. And let's see what it does. All right, so the leaders are moving. They start to separate. They have a bit more of a erratic motion, which is interesting. So at least that part is working. But one thing I want to also point out is that these leaders are, getting further and further away from the center. And these kind of shots, the camera guys always has them in a group. They don't tend to spread out into infinity. And that's something that we need to tweak as well. We want to have them within a certain area in here. So there is a force field that we haven't used, at least on its own. We haven't used it yet. That would allow particles to be pushed away from a point. But if you invert the magnitude, then we get attracted to a point. So there's one of them that we could use, and it's called the radial field. But the thing with the radial field is that, well, I want to show you. Why not? I created one, and I selected the leaders, right? I don't want the swarm itself to be affected by this force. The radial field is right here. If I zoom in, but I can't zoom in, but this is just a bunch of arrows pointing from the center out, just the same as what this emitter looks like. Pretty much the same without the box. So it tells you what it's doing. It's just taking particles from this point, which I'm going to put them right in the center again, and it's pushing them away. It has an attenuation. You can put that to 0, and it has a magnitude. For the sake of testing, okay, I'm going to grab these particles, which is a swarm, okay, and I'm going to disable them. If you hit this checkbox in here that it says is dynamic, then they won't be simulated. Because I want to focus first on the behavior of the leader, because the leader is the key. If those guys don't move around correctly or they don't do what you want, then the whole group, because it's following them by association, then just stops to work. So you can see that the radial field just pushed them away. And they will continue to go away. The turbulence is doing something, but the force is always pushing them away. If you invert the magnitude, then the problem with this is that the particles will just zoom in. They'll be born, they will start to be pulled in, and eventually they will stop in the center. Obviously, the turbulence is fighting and is kind of doing something. But I don't like the fact that these guys are on top of each other, all three. That's not going to be nice. So, yeah, it's doing something, but it's not really interesting. We can probably change the turbulence frequency. Put that back to 1 and try to break them individually. I still don't like it much. You can play with these numbers and force them to do something different. They start to separate a little. But what I'm trying to say is the point of the radio field is they will eventually stop them in that particular point. If I put the turbulence field to 0, you will see that the particles, they will eventually come to rest right at the center. So that's not really what I want. What I want is a field that it will kind of let them move out and back in and back out and back in and stay within a certain area. And the field that I want to use for that is a better one, which is called the Newton field. This one. So the Newton, imagine the symbol of an atom. Okay, so it's concentrical rings. Okay, in the different directions. So this field will push and pull, and almost describe a shape of an atom, at least of the say that the icon that we use, or the part for the form. So the Newton field right here also has an attenuation, which I don't want. And this magnitude now, think of a radio field that will just turn on and off, or go from the negative magnitude to a positive magnitude. It's almost the same result. All right, so let's see what that does for us. And oh, sorry, I didn't rewind. There they are. So these particles will get pulled and then pushed. And let's just increase the magnitude to see. You have to keep an eye on something as well. Some fields, and not all of them, but some fields come with something called the max distance activated, or the min distance. So keep an eye, because sometimes, right now it's not using max distance, so it's fine. If you were to use max distance, you're limiting the effect up to a certain distance away from the beginning of the force, or where the force is located. So keep an eye on that. Right now, let's increase the magnitude and see the effect. All right. Similar to what the radio field is doing, I don't like. I'm going to increase this distance. Okay, here we go. Let's rewind and play. So this distance is definitely using this value to work. So I'm going to put that to 0. All right, let's see what that does. Okay, so it's a similar behavior, which is kind of stupid. Let me just look in here, my attributes, apply per vertex, max distance, I don't want it, volume exclusion, no. Also, everything is fine here. Volume sweep 360. I'm gonna go crazy with the magnitude and see what it does. I'm also gonna check the conserve of my particles. Yeah, it's fine, it's 0.98. All right, let's push it and pull it. Let's see when we combine it with the turbulence, what it will do. So grab this turbulence and put this to, let's say 50. I'm really making these things work. Okay, so it's doing something. They're a bit too close, so I'm gonna grab the magnitude of this and I'm gonna lower it to 100. Okay, I like it, but they're still too close. Okay, So I want them to have some sort of range of motion that let the turbulence push them around, but then have the Newton field remind them that they have to stay close. They're still too close. I would like to have them in this area. So what you do is you start loosening up the amount of the magnitude of the Newton field and just let them hang and let them be. All right, so that's good. So that's an attribute that we need to keep in mind. The magnitude of the Newton field is the one that's going to dictate the overall size of how the distance where the leaders may just separate. And we can incorporate that into our little system as well. All right, so I have now a more interesting motion, a bit more natural behavior for the leaders. So I think I can reactivate my swarm particles. So it's dynamic, turned on. Let's rewind this thing, save it. All right, let's see what we have here. All right. All right, sounds good. Okay, so that part of this, one of the issues has been taken care of. We can always turn it down later. I think it's better to force and amplify the results of the effect at the beginning so you can really see the changes. And then you can start taking all the numbers down and make it more subtle, more natural. But for now, I think it's working well. One thing that remains, and I don't like, is that all the particles of the swarm seem to have the same attraction towards the leader. And like I said before, I want to randomize as much as possible this value. So I don't want the particles to have the same attraction, all of them. I want some to be closer, some to be get left behind, some might almost have no attraction at all, because that's the way it works, the natural behavior. But the problem is that if I grab my particles and I go into my channel box, then I have just the one main switch for everything. I can switch the goal weight. I can just say, yeah, well, try 0.1. It's a lot less attraction to the leaders. And they start to, separate a little bit more, and then, they kind of remember, but they went away. They know that they're coming back here. There you go. And it could work for some situations. But still, that doesn't solve the problem. All of them have the same number, the same attraction. So that's not the solution. The solution is going to be something different. It's going to be with that expression. So this is a 0.2. All right, so we have something cool. I like it. So how do I place a different goal or a different goal weight on each one of the particles? If you select the particles and go to the shape node, if I want something to be on a per particle basis, remember that we have to come onto this tab, the per particle array. And here I have a list of attributes that each particle can have a different value. And one of them, as you can see, that wasn't listed before, is now here. It's called goal PP, and then that's the guy who's going to be responsible for assigning each one of the particles a different attraction. This is an attribute that is going to multiply by the main goal weight, right? So whatever the goal PP has, it will multiply by this number, and that's going to be the result that you have. So with that in mind, what I want to do first here is always put my goal weight to 1. If I want to test my expression first, if I want to see the result, because whatever I put here multiplied by 1, it is going to be this number. If I leave it at 0.2, then it's going to be 20% of whatever I specify in my expression. Now the next question is going to be what? Do I want these particles to change their amount of attraction over time? Or do I want them to be born with a different value and that's it? Well, it's up to you. But in this case, I think it's easier if you're just born with a value and then just stick to that. Let's say that some birds are more attracted to that particular leader for some reason, and others don't, and they stay that way. You could modify that on a runtime basis, on a per frame basis, but that's something that you could try in your homework if you want. I think for now, we're going to do what is called a creation expression. We copy the attribute. And here what I want to do is just randomize it. I want to give each one of them a different number. So I use the random expression. We used it before in what I think was the first lesson. and you need to specify a minimum and a maximum number. I saw the 0.2 was a very good number for this kind of attraction. Okay, so they're kind of close. And 0.1 that I tried before, they just went away and then came back later. So I'm thinking somewhere in between, sorry, 0.15 and probably 0.3. It could be a good number. So a little bit more than what I have right now and a little bit less. So it's somewhere in between those two values, we're going to place them. Let's see. It could work, it may not work. All right, so now you can see the gold PP has an expression, and these particles will now, when they're born again, they're going to have a new attraction value. So let's rewind, save it, and hit play. All right, definitely much better. You can see now that they have like a little trail. So these guys here will have a higher attraction than these guys over here. And you can actually see this in real time. You can select, instead of points, you can switch them to numeric. And if you hit this guy, then you can specify here to show you gold PP. And you can see that these guys have 0.151 as a gold PP value, and the ones closer to the particles here are 0.291, 0.289, 294, so all close to 0.3. So there we go. Back to points. Good, let's see. I like it. We could tweak it a bit more. You can play a little bit with the values. Remember now that you have a good, good tool right now, using the gold weight as a main switch. So if you want to have half of what we specified on the expression, you don't have to tweak the expression. You can just tweak this number. And right now we're going to get a lot less attraction. You see, this is a value of 0.5. 0.5 what? 0.5 of what I have. So 50% of what I'm specifying in the expression. The expression set at random between 0.15 and 0.3. So now will be half of each of those numbers. So this is a good way for you to tweak it. And if you put it to 0, there's no more gold. They just go along with the turbulence field. They forget about the leaders. But if you want to go back and bring them back to in line, let's say, put up at 0.7, they will rush back in. There you are. They will rearrange themselves. So this is always an effect that you will look from the distance. If you start putting the camera too close inside the group, then trouble might be. Now I think it's a good time to take the spheres and just put them to points and just forget about them. Then you start to see the real deal. Overall swarm behavior. If you have the spheres visible, then your eye is always going to say, I know what's happening. I don't think I like it. But I think this is working really well. It's a good opportunity for us to try a bit more particles. So grab this system and then just put 10 times more. Probably up the rate on this emitter. 10 times higher. All right. Still emitting particles. There we go. It finished. So these are 15,000 birds, let's say, following only 3 leaders. Let's say that we want to have some more leaders and see what it looks like with more. No worries, you grab your leaders. Instead of 3, let's put 6. 3 more are born, they start to separate. You see, it could happen on any moment. I mean, if you introduce more leaders, they will just divide themselves, and some of them will go with the new guys. You could also try streaks. Remember, the streaks are very cool for this kind of motion. It gives you a little motion blur, makes it more natural. So I like it. I think we have it. This is working. So let's make this into a little system, just like we did before. What do you think? I'm gonna save my scene. I'm gonna make myself a locator. There it is. I'm gonna make it a little bit bigger. I'm gonna put it to the side maybe. I'm gonna be a little bit faster than the previous lesson because it's the second time we do it. I don't want to go the same speed in every exercise. It's boring. I'm gonna go to Window. If you want to know the why and how and everything, just move back 2 lessons, I believe, 2 or 3 lessons. The description of each video has what we talked about. So go there. I'm going to go to my channel control and I'm going to get rid of my rotations. Everything. Just going to get rid of all these things. I'm going to leave my locator with no attributes on my channel box. Just this guy. Then I'm going to add some attributes. First attribute is going to be what? Let's say just swarm size. Swarm size can be, let me just think, because it could get confusing later because that might be an attribute that we could use for the overall separation of the leaders from the center. So why don't we call that swarm count? I think it's going to be a float because it's a simple number. Minimum number. Let's just not make the mistake from the previous one that we just put it to 0, because if I want to have unlimited birds, then I want to have minimum, -1 is my minimum, no maximum, and a default of, let's just say 150,000. I'm going to hit add. That's my attribute. I'm also going to have leader count. Same idea, -1, and then no maximum and a default of 6, which is what I have right now. I'm also going to have turbulence high. I think we should be more specific. Swarm turbulence high, because I'm lazy. I'm going to copy this. This is also float with a minimum value of 0, no maximum and a default, of 25. I'm going to paste that. Low, 0, and also 25. I'm also going to have now my leader turbulence, and that's going to have a minimum of 0, a maximum of I don't care, and a default of, I don't know, I don't even know what I'm using, but let's say 50. We'll tweak it later. I'm just adding attributes, remember. I'm also going to have, let's say, leader separation. I don't know. It's just how far they want to move around. Minimum of 0, and this I don't remember, but let's put 35. What else can we do? Let's see. That's the size, the turbulence. Well, of course, the attraction. So we can put swarm goal weight overall. And the goal weight is going to be 0. The maximum, I'm going to leave it the maximum open, and then we'll see if we need to tweak that later. And then this, let's just say 0.5. Hit add. Okay, I think for now we have that taken care of. Let's just go and connect everything. So right now my swarm is working. Cool. All right, let's go ahead and connect a few things, the simple ones first. The swarm count is the max count of the swarm system, right? So I'm going to grab my locator, window, general editor, connection. On my left is my locator. On my right, I'm going to put the shape node. So if you grab the particles like that, it's not the shape node of the particles. You need to hit the down key on your keyboard. That's a shape node. Reload them here. So I'm going to grab then my swarm count, and I'm going to connect it to my max count. Perfect. The next attribute on my list is the leader count. So I'm going to grab my leader particles, hit the down key on my keyboard, reload them on my right. And the swarm count is going to be connected to the leader shape max count. Next one on the list is the swarm turbulence high. So I grab my swarm turbulence, I grab my swarm turbulence high field that is right here. You see the naming is very important for this. And I'm going to connect it to the magnitude. Swarm turbulence low, reloaded, low, with magnitude of the low one. You see, it's very, very simple, very quick. Leader turbulence, I'm going to grab my turbulence, reload it, leader turbulence with magnitude, everything is connected. Next one on the list is the leader separation. Leader separation has to deal with the Newton field magnitude. So reload that. Leader separation with the magnitude of the leader. Beautiful. And the swarm goal weight, going back to this guy. Shape node, reload. And I'm going to need the swarm goal weight is going to be connected to the goal weight 2 attribute, right? So goal weight 0, 1 are the two locators that we made at the beginning of the lesson that I deleted, and then 2 is what I need. You see, very simple. I think it took less than a minute to connect everything. Save your scene just in case. Let's see what we get. We're going to get a bit of a funky result probably because, all right, you see, we have a problem. Well, many problems, but one of them is the leaders are not, the leader count, it didn't take it. So I probably made a mistake here. Let me just grab my locator. That's my swarm count. Leader count is set to 6. Probably I connected things the wrong way. Let's just double check it. Because if I grab my leaders, it says my max count at 150,000. So that's not right. If I grab my particles of the swarm, this is correct, 150,000. So probably I connected the two particle systems under the same attribute. So no problems. We grab it. Window, general connections. And we're going to grab the leaders shape node, reload it, and then we're going to grab the leader count and make sure we connect it to the right thing. Max count might show up as gray because it's connected to the other guy. So right now the max count, as soon as I connected those two, you can see that now here it changed to 6. So that's correct. So that's the first problem resolved. Save it. Okay, so we get 6 liters. We have a bit of an issue with the goal weight. And also with the rate of emission. Right now I can see that this emitter is still outputting particles. So let's make sure that our max count right now is 48,000 particles. All right, so I think it's just taking too long to emit, but that's okay. But at least the max count is working. Just right now we're not getting anywhere near the number. Probably I put too many zeros. But yeah, I think it was 15,000 we had in the effect earlier. So that's not a problem. We grab the locator and just take a 0 out of this. Rewind, hit play. Now we should have 15,000 birds. Just make sure. There we go. Perfect. But we do have a bit of an issue. Well, I mean, it is working. I just think the goal, that amount of attraction is not enough with the leaders, so we need to increase the goal. So grab this, and we have a goal weight set to 0.5. Let's make sure that it's connected to the goal weight of the particles. So goal weight 2 is set to 0.5, so that's working fine. So grab the locator and let's test it. Let's put back to 1. Hit play. All right, so it is working. Everything is fine. I think what I had in the example before we turned it into a little system in here, we had it at 0.7. So now it's very easy for you to keyframe the changes and make it, behave differently. All right, I like it. It's working really well. We have control over the turbulence and the whole thing. Let's make sure that the leader separation value is working. Let's just increase that number to 100, and they should just, let's see what happens. They just go into the center. They will go really small. Okay, let's find the leaders and see where they are. There they are. Okay, the 3 little green points. 6 little green points, I'm sorry, and they're really close to the center. If I grab this and release them, or the little separation, if I put it to 10, you see the group starts to open up and get bigger. If I put that to 2, they start pushing even further away. Excellent. And each one has its own turbulence that you can control separately. I like it. It looks really good. Beautiful. That was quick. Okay, so I'm going to save my scene. And this is one part of the assignment. This lesson will continue. What I will do is pause this one so the videos don't get too long. We're going to move on to the next chapter now, the next lesson. But for this lesson, I want you guys to go ahead and replicate this. Play some cameras around and then give me something. It doesn't have to be nature-like. If you want to have something a bit more sci-fi, science fiction oriented, be my guest. I love it. I want to see it. But I think with this, we're fine to stop at this point. So, well, thank you very much. I'll see you in the next lesson. Goodbye.